Welcome to the last session of the daily Bytes around cloud this time of the year. Hopefully, we'll find another topic later on. But to finish this off, the topic I want to talk about today is pricing. Pricing is one of the things that's always very confusing and people get annoyed if it's not very clear. So let's see how pricing at Elastic Cloud works. It's generally resource based. So it depends on the resources you use on Elastic Cloud. It's not agent based, like by the number of agents that send data. It's not volume based, like you log 100 gigs of data per day. It's really what do you need in terms of instances to store all the data that comes in and to do all the ingestion, and then enough resources to answer all the queries in the right amount of time. That's what is the pricing based on. I will be using the pricing calculator, and I'll share the link in chat. This is the pricing calculator where you can actually look at what you have in terms of instances available to you. We support all the three major cloud providers. You can then pick the region. So for example, for me, I might say West Europe is closer to me. And then you have different hardware profiles. The number of hardware profiles also depends on the cloud provider. So with Azure, you have the least, you have general purpose, which is like for if you have like a logging use case for something like 5 to 7 days of data. So it's a reasonable mix of CPU and memory and storage. You have storage optimized where you have higher density, so you can store more data, but it might be slower at ingestion or at search time. And then you have CPU optimized, which is good for higher ingestion rates and higher search frequencies and lower response times. But has less storage, for example. So you can pick depending on what scenario you have, if it's more like a full text search scenario, or if it's more like you want to store more data and keep logs around for longer, which you will not search so much. So you can pick that hardware profile based on that. If you pick, for example, GCP, you have another kind of like setting here for general purpose. And if you switch over to AWS, then you have ARM instances, which is the new pretty efficient, also energy efficient CPU that Amazon provides. Generally, if you have those available and they fit your needs, pick ARM because they are relatively price efficient as well. So we have done some tests and we have been winning some single double-digit percentage in efficiency by using the ARM CPUs. We have those for general purpose and CPU optimized. So they might give you the edge in performance and cost if you need that. Once you have settled on the cloud provider, the region, and the hardware profile, you can then configure the data tiers, hot for ingestion and like the current data that is being searched. And then you have warm, cold, and frozen as the older tiers where you can also store your data. You can just click them together. For example, here, let's say I want to have at least 2 availability zones. So if one availability zone goes down, I still have the replicas in the other zones. So my data is always available and my cluster is always live. Let's say I want 8 gigs of RAM, which gives me 240 gigs of disk. Then I also add a warm tier. Let's say I go for 5 terabytes of data on the warm tier. I skip the cold tier and then go for frozen again. You can see a warning down here. Once you hit 6 nodes, we add dedicated master nodes for the stability of your cluster. So you can see these are automatically configured according to your needs. You could, if you have, for example, a lot of shards or very large mappings, you might need to increase the size of your dedicated master node. So for example, this is an overkill probably for this cluster, but I would go with this, and then this is the cluster that I have clicked together. You could add a coordinating node as well. These are for your client requests, but if you have an ingest pipeline, this is also where the ingest pipeline would be running. So for example, if you click on info, it will always tell you these are the roles that this node are taking over. So this is coordinating for your client requests. But it is also doing that ingestion, which is pretty CPU heavy. That's why you might want to put that on a dedicated node just to let all the CPU do its work there, and then move the data to the rest of the nodes for the actual storage and querying. And again, I could pick 2 zones and then say like, this is what I need in CPUs on this one. If you need machine learning, add machine learning. This is something that will otherwise fail in Kibana, or you will get errors in Kibana if you try to enable a machine learning feature and you didn't add a machine learning node. So you can add that as well. Kibana is included in this as well. One single instance with this configuration is included for free. We also have the integration server, which is again, the smallest size in a single zone is free. This is what used to be the APM server and what you need for Fleet. So this is the integration server that you have, and enterprise search if you want to use workplace search or app search. If you don't need those, I mean, these are free instances by default in single zone, smallest size, but you can just still click them away. So I have a pretty large cluster by now. This is what I have in Elasticsearch. And then you can see these are the free resources in integration server, Kibana, machine learning, APM, and enterprise search. A single zone in the smallest size for those is free. If you don't need them, you can still just click them away, especially when creating the cluster. It might just take a little longer otherwise. So this is the cluster I want. It shows you this is the distribution of my nodes over the availability zones. Gives you a rundown of the architecture. And you can also see this is what this currently costs. So this is like $4.50 per hour in the base configuration. There's also something to mention here is the subscription tier. The subscription tier has 2 things. It has features. We don't enforce those right now, but we do send you a warning screen if you're using features from a higher tier. The other thing that you will notice immediately is that the support tier depends on this. So the standard support is only business days, and it might take some time. I think we have an SLA of 2 or 3 days until somebody responds. If you have a production setup where you say like, oh, we need somebody to respond within an hour, even on the weekend, because our use case is so important, do not pick the standard tier. Pick G is for gold, that is platinum, that is enterprise. They have different levels of features and then support. And if you, for example, pick enterprise, it will increase your price accordingly. It is a bit like with AWS, for example. You can add a higher support tier on top of what you need to give you that peace of mind and actually get stuff done on the weekend, for example. It's pretty much the same thing there that is kind of like added to on top of what this costs. These were kind of like the fixed hourly costs. Then there are also additional costs about data transfer and snapshots. And it's sometimes a bit hidden. I'll post a link as well. So for so that the 2 things that we price here in addition that is usage-based is blob storage, so like Amazon S3. So we charge this amount per gigabyte per month of blob storage that you're using. And then per 1,000 API calls, this is the price. Data transfer within the availability zone and in is free. Data out costs this amount, and then so out of your deployment for your application wherever that lives, and intra deployment between availability zones, this is the price of the data that you have here. It has 100 gig per month free allowance, which is enough for many smaller use cases. If you have a very large use case, this might be something that could be adding some amount of cost actually. Also for API calls and S3 storage, there is a free allowance. So most small setups will never see these added price items. Larger ones might. We have recently made some improvements because this data transfer between the nodes used to be quite expensive. And we have a kind of like a workaround built in now because the blob storage transfer is always free with the cloud providers. And for example, we have a very large setup, but our own setup that transfers a couple of 100 terabytes a day is saving $100,000 a month by just having this optimization. It's just something that is built into cloud to keep that cost down. And you need at least Elasticsearch 715. So if you have been suffering from high network transfer costs, update to 7.15 or later, and then you will have this optimization, which can have quite an impact on your service cost. The final question that we always get is, since this is resource-based and I need so much memory and CPU and whatever, how do I figure out how much I need? So there are kind of like two ways to calculate that, and I'll share again this blog post. We have put that together to actually give you some idea of what you might need. There are, I think, two ways to think about this. First, I want to store X amount of data per day, and I want to keep it for a month or whatever time frame you need. Then you need at least to have that storage to store everything in your cluster. Then there's also the overhead of like, how much memory do I need to answer all my queries in the right latency? Or how much CPU and memory do I need to ingest all the data that is coming in? And for that, we have our performance benchmarking tool, Rally. This blog post walks you through the different considerations here. So that by volume is relatively clear. How much volume per day? How long do you retain it? This is the hardware that you will need. And with Rally, you can basically say, this is the scenario that I want to do. This is how much data I need to ingest at most. How many nodes do I need to do that in the right amount of time? And like I said, Rally is that benchmarking tool, and we have preset scenarios basically of what we need, but you can totally build your own to figure that out upfront and test it on the hardware. And then here we have looked at a couple of scenarios, like how many clients should we have in parallel and how many nodes are we doing that, and where do we have like the optimal intake on our nodes. Also in one of the other scenarios, we have looked at a 1-node, 2-node, and 3-node cluster scales almost linearly in this scenario at least. So you can figure out like, I can do that much with 1 node. Totally, I have maybe, I don't know, at most 60,000 requests per second as throughput, then I would be fine with those 3 nodes here. And you can just benchmark this together. And also I've shown you on Tuesday, the monitoring in the cluster. So we have shown here a lot of benchmarks, but in the monitoring cluster, you can see like what is the current throughput. So you can run these scenarios basically. And with the monitoring cluster, you could see how is my cluster doing and behaving. And you can figure then out how much hardware you need. Our favorite answer for this is always, it depends. How much hardware you need really depends on your scenario. But hopefully by benchmarking or having some experience or just starting and then auto scaling, since we support it as well, it should get you started. And then with the pricing calculator, it shows you how much that will actually cost you and what is the scenario that you can put together here. I hope that made pricing a bit clearer. It can sometimes be a heated debate. CEST is always happy to help you out if you have any specific questions, or if it's more technical, ask us on Discuss, and we're happy to kind of like try to guide you in the right way there as well. Thanks a lot for joining this season of the Daily Elastic Bytes. I think we'll be back. We are still trying to figure out what will be the next topic. If you have a specific topic that you want to see from us, let us know and we'll see what we can do. Thanks a lot for joining and see you next time.